Hi, everyone. Welcome back. We are here for the third panel of the day, which is To Infinity and Beyond. I am amazed by this panel at the moment. We have 4 women in space and aerospace industries, and I'm so excited for them to be speaking with you all. So we have Miss Sophie Harker, who is currently working with InSpace Missions at, I think it's with BAE Systems, but she's an engineering manager there. We have Miss Kinjal Dave, who is currently working as a defense consultant with BAE Systems. We have Cheyenne Powell, who is getting her PhD in, I want to say, explainable AI for space. And then we have Ms. Hasret, who'll be joining us as Ms. Hasret has quite a few titles. She's a economics professor, a microbiology and immunology expert, and she's a certified lunar analog astronaut, which is actually something that she has in common with Sophie because they're both analog astronauts. Okay, so just give me one moment. I just want to be able to introduce the panel. But in the meantime, just some quick housekeeping. So we do have quite a few panelists for today, but I want to be able to introduce you to all of them and also give you the chance to network. Because here at the LinkUp, the main thing is to see it, is to be it. And I wanted to be able to show you girls how many, that there are role models for you in the space and aerospace industries. And not only are there so many for you, they look like you, they're successful, they've been where you are, trying to get into all these things, and they're excited to share with you and just really be your role models and to show you what's available and what's possible. So as a bit of housekeeping, we will have time for you at the end to actually communicate with these ladies and actually kind of speak with them a little bit. So if you would like to speak with any of them, feel free to raise your hand and I can unmute you and let you have your own little time to speak with them. And also for the Bermudian students, if this is your third time visiting us, we have a giveaway. We have our LinkUp t-shirts. You get the LinkUp on the front and then the different sponsors that we have on the back. That's for the Bermudian students. If you are between the ages of 10 to 17, then this shirt is available for you. I have a little wonderful giveaway bag that I'm hoping you can see, but not really. Oh, there you go. Nice and colorful. So we have our Digicel gift card, which is the $100 to Digicel. So if you're based in Bermuda, that'll be wonderful for you. And then just because of my own experiences with trying to get into robotics, I wanted to give you guys a little Arduino. So it's just an Arduino Nano, but it does connect to the Wi-Fi. And I thought it would be a good stepping stone for those of you that are interested in getting into robotics or just kind of playing with it because the Arduino is quite versatile. So I want to give that to you as well. So if you attend 4 sessions and you're based in Bermuda, that'll be the wonderful gift that you'll get at the end of the day. So, okay, I'll give myself a second to pause and then I'll just kind of introduce the session. So, in today's panel discussion, we have the privilege of hearing from 4 remarkable women who are making significant contributions to the fields of space and aerospace, which are 2 different things, and I'll get them to explain it to you in a moment. So each of our panelists is bringing us a wealth of experience and expertise, ranging from cutting-edge research in AI and space engineering to groundbreaking work in defense consulting, STEM education, and interdisciplinary science. So whether you're a high school student who's been dreaming of a future among the stars or a university student preparing to launch your career, pun intended, this is the session that will give you valuable insights into the challenges, the opportunities, and the exciting developments in the world of space and aerospace. And I'm so excited to link up with all of them today. We're just going to go ahead and get started. So I will ask you first, Ms. Oak, just because you're the first one on the panel. So if you could just introduce yourself and tell us a little bit about what you do and then how, introducing yourself and your role. Sorry, for Sophie first.
Sorry, I didn't know. I had a different name. Never mind, it's all good. Hi everyone. So my name is Sophie Harker. I'm currently the engineering manager at a company called InSpace Missions, which Cameron's rightly said is actually part of BAE Systems, and it's getting merged into the wider, bigger business at the moment. But what we do is end-to-end satellite missions. So we design the mission, we build the satellite, we build all the components that go with it, we do the launch, and we do all the data analytics while it's up in space, and obviously the decommissioning when it comes down, as well as some of the data analytics on Earth. So a whole host of different things. You need lots of different types of engineers, lots of different types of scientists and data scientists and things like that. Really interdisciplinary, but a lot of fun. And prior to that, I was at wider BAE Systems, so at a different part of BAE, working on lots of different types of aircraft. So I've got experience in aviation and in space. So working on things like electric aircraft, UAVs, so uncrewed air vehicles, so basically big drones, fast jets and hypersonics and space planes as well. So a whole host of different things. And that's me.
So thank you so much for introducing yourself. I'm going to move over to Cheyenne now, if you wouldn't mind introducing yourself to the students and a little bit about what you do.
Thank you, Cameron. Hi, everyone. I'm Cheyenne Powell. I'm from Jamaica, and I am currently a PhD researcher in Scotland, working on explainable AI for robust spacecraft mission planning and scheduling. A bit about myself. So I did my electrical engineering degree in Jamaica at University of Technology, where I worked as following that, I worked as an automation and robotics engineer in the manufacturing industry for 7 years. So I started off at Red Stripe. I'm assuming that, well, not assuming. Red Stripe is a beer that is manufactured in Jamaica. So I know it's popular across the Caribbean and, of course, in other countries as well, such as the UK, where I'm currently studying. Following that, I relocated to the UK to do my master's in astronautics and space engineering, where I developed a microalgal photobioreactor for life support systems for deep space missions. So following that, while I was working, I ended up doing the PhD in explainable artificial intelligence. And what I mean by that is getting the AI system to speak for itself, explain to you what it's planning to do and why. So yeah, that's pretty much I'm also the founder of a space company called Depart Norm, and that's where we be providing explainable AI solutions for industries. And I also have a severe nut allergy, food allergy, where I'm also the founder of Allergy-Free Goods, where we supply goods for those who suffer with food allergies for international travels. Thank you.
Amazing. So I'm going to move over to you, Kinjal, as well. So you can just introduce yourself and a little bit about what you do.
Yes, hello everyone. An absolute pleasure to be alongside with these wonderful women. So I am Kinjal Dave. I am an engineer by profession. I am a dancer by passion. I like to write and dance and sing, but it doesn't pay the bills all the time. So what you do is you do it as a side hustle, as Gen Zs call it nowadays, and do your hardcore cool engineering and cool consulting as your day job. And then you discover the nuances and you understand that actually that is so much cooler. So if there's anybody listening, working as a defense consultant, I mean, both Sophie and Cheyenne have sort of touched on the kind of versatility and the variety that space offers as a career. But I'll definitely say, I work with weapon systems sometimes, software solutions, data sets, and it's really cool to see sort of a soup to nuts approach, or pardon the pun, Cheyenne, or the cradle to grave approach on systems, on parts, sensors, whether it's something live, something solid, or something like a software. In my spare time, I have lots of fun attending events like this. And my master's was actually in nuclear energy. So if I ever go back into academia, I think I'd like to focus on propulsion for deep space, using nuclear energy for the greater good, like space exploration, if and whenever that may be. So yeah, that's me.
And I'm going to move over to Miss Hasret as well, if you wouldn't mind just kind of unmuting and introducing yourself, and then a little bit about what you do.
Hello, everybody. I'm very pleased to be here, and I'm really admiring Cameron because she's a student and she's making a lot of fantastic things. Okay, let me introduce myself. I am a professor of economics. I've spent like 30 years working on business and education sector. I have started from the beginning as a student like you. Then I have graduated and I have just think about stairs, just think about a ladder, step by step. Because with the impact of my parents, because I was always asking my students if they like whatever they are doing, because sometimes they were telling me that because they are in that field, because of their parents, the parents wanted them to be there and other things. When I was a child, I was inspired by the small things, in fact, like the ants on Earth and the stars. But my mother was not happy with that at all, because in our time she was coming from a small village, she was uneducated, and my father was a bit educated, let's say, and our environment was not so much improved. So she was telling me, just become a teacher and learn how to manage your life and manage your money and just continue your life, marry with a man, have children, and like this. But I said that, okay, let me move in that way, but I don't want you to become sad. But my passion was with the space and the biology all the time. But because of my father and the environment, I have continued to be an economist, because managing the money, budget is really very important about everything. Because sometimes my students were telling me we hate the maths and other things, but I was telling them, you are involved in math, because whenever you are going to a market to purchase a chocolate, a simple chocolate, you are just taking your money out of your pocket and you are exchanging with the chocolate. You put the chocolate in your pocket. That's the mathematics there. That's the economics there. So economics is the simple thing starting, in fact, while we are a child. So I have moved in the education sector as well. I like to teach. I have noticed that I like to teach. And I have the eager to get myself developed, experience, and because I believe in the lifelong learning as well. So if I want to reflect that one to the young people, I should have the necessary knowledge. So I have started the steps and come to become a professor. But I have persuaded my family anyway, and I have continued with the microbiology and immunology. That was my passion. And I've combined it with the space. It was coming from the little tiles. And then because my mother was preventing me to become that way scientist, I was inspired by the art as well. While I was a child, I was just trying to draw everything that I like. And I was reflecting my thoughts, my psychological views, and everything on paper. So whenever I go to become a lunar analogue astronaut, I have seen the space dragon, the drawings and everything. And so I said that, okay, the digital art. I like the digital art. I can express everything with that. So I am involved in the digital art as well. My family liked the sports. And because of that, they have trained me in that way as well. So I have become a professional athletics, and I have joined the international competitions as well. I was successful there. I liked it. And we have come to these days. And now I am teaching at Oxford Academy of Excellence for the young people. There is a special program there, like the Cosmic Girls. And I'm a volunteer working as a researcher at the Colorado. They are giving funds to young people to educate them and other things. So I have been in many countries in international environments. I like young people because, while you are becoming old and everything, you left everything to the young people. So the young people should handle with the difficulties that the old people have caused on Earth. So,
no, I don't want to leave you, but I will 100%. I'll be coming back because you, like, all of you have been so interdisciplinary. You all have so many different things that you're working on. For example, Cheyenne, you're working on the allergy things outside of your interest in space. Kinjal, you're still looking at nuclear things on top of the defense work that you're doing. Sophie is a pilot, I believe, a pilot and also an analog astronaut. Hasret's on economics and arts. It's just, oh, it really just showing how, I guess, interdisciplinary and versatile it can be, not only just like in space and the aerospace industries, but also just as women in STEM. I feel like we all have quite a few like really diverse interests and things that you're all focusing on, which is something that I really wanted to show the students at this conference. So we're looking at the main theme of just to see it is to be it. So I wanted to bring together all of you to kind of get you to speak a little bit more about the space things so people can see like, okay, so we have 4 wonderful women that are working in it. I can definitely be in there as well. That is the goal, and that's what we're going to be working on. So I'm going to start asking a bit more space-based questions. Don't worry, they're coming, guys. So I wanted to ask Sophie specifically because you and also Ms. Hasret are both lunar, like the analog astronauts. So for those of us that don't know what that is, can you please explain it? And then how did you get into that? So I'll go to you, Sophie, to explain.
Yeah, sure. It's an unusual thing that a lot of people have never heard of. Even those in space industry, it's quite a still niche within space industry. So it is unusual. Essentially, what an analog mission is you're simulating a space mission but down on Earth. So if you're doing a lunar analog, you're doing a moon mission but down on Earth. If you're a Martian analog, and obviously you're doing a Mars mission down on Earth. And that can be in a number of different ways. So you could be doing it either you're sort of isolated from the outside world, both digitally and physically. You could be doing it underwater in like extreme environments. You could be doing it in a cave. You could be doing it in Antarctica. You could be doing it all sorts of different places. And the purpose of this is, well, the number of reasons you do this. One of the reasons is a psychological factor. So how do a group of people who, well, in my case, when I went on my first mission, didn't know any of them really. I knew one of them briefly, but that was about it. How do they deal with stress? How do they deal with, again, in my mission, a lack of caffeine and lack of sugar? How do they deal with no sunlight, being cut off from the media and from their family and friends? Those sort of psychological elements for sort of long-term missions, like if you were traveling to Mars or if you got cut off from the Earth while you're on the moon. They also do sort of other types of experiments while you're there. So whether that's de-risking certain types of technology, whether that's exploring different experiments around, say, a rover and understanding the human interface to that. It could be looking at sort of a microbiome generation within an enclosed environment and what survives and what doesn't. There's a bunch of different things that you can do to essentially de-risk space travel, so that when we do send people back to the moon and we do send people onto Mars and possibly beyond, that we are doing things, we've somewhat tested some of these things as best we can on Earth. And so an analog astronaut is just the person that is the astronaut in that mission. So they're down on Earth in the facility actually testing.
Fascinating. And speaking of really fascinating parts of space, I feel like with Cheyenne, with the whole, I think with AI now, it's become quite of a bit of a buzzword, but I don't think that many of us are thinking about it in terms of the space side of everything. So I wanted to ask if you wouldn't mind explaining, like, what is explainable AI? And then what also motivated you to decide on focusing on that for your PhD research?
All right, so explainable AI is getting a system that has an existing AI system built on, getting the AI system to communicate to you, explain what it is doing and why. So currently there's a challenge of, for example, you see an autonomous robot in front of you, you want to speak to it, you want to say, why are you doing this? Could you do A instead of B? Now, getting the robot to actually analyze your question, look at the situation, see what's happening around, and then speak back to you saying, I'm doing A because B isn't possible right now because there's an obstacle in the way, etc., etc. So being able to communicate that is what I'm working on. I'm developing an interactive layer that allows you to communicate to the system. So for these space missions, or for Earth observation satellites, for example, there's an issue with communication to the ground station. So engineers on the ground station are unable to communicate with every satellite at any point. There are challenges, and then they have to schedule the times when they can send instructions to the satellite, depending on where it's located, its coordinates, or what orbit it's in. And as a result, there could be instances where emergency situations can happen, and you'd want the satellite to respond on its own. And being able to respond on its own would be based on the trained data. That's where AI comes in, enabling the system to assess its environment, assess the scenario, and make a decision without any human interaction. So getting the system to respond autonomously to protect itself and the mission. So collision avoidance, for example, that's where one word would be useful, which is being developed. But when it establishes communication to the ground station, the operators might be wondering, what happened? Why do I have, for example, less propellant? Or if it's an Earth observation satellite, was there a storm? What happened? Why couldn't I see why couldn't I see images of this land? So getting the satellite to say, okay, at this time, on this date, this is what happened. I didn't have enough power to take images or to scan the areas using my instruments on board, or there was an error due to whatever it could be. That is what I'm actually working on, enabling the ground station operators to get an explanation of what happens on board. Also for deep space missions where communication is even more limited, and there could be times where catastrophic incidents can happen and you lose the satellite completely. Sophie mentioned getting astronauts to the moon and to Mars, especially when you have life on board. If the astronauts are stressed at certain points in time and a decision has to be made, getting an AI system to assist with that and explain to the astronauts that this is what I'm going to do. This is why I'm going to do this. What do you think? That's where human in the loop will come in. And with that would provide a lot of support and assistance to the astronauts, not only to the astronauts, but also the ground station operators and everyone else on Earth who's wishing and hoping for the best of this mission. That would also save a lot of money as well. And of course, lives, definitely lives. So that comes first, safety comes first. So that's where explainability will come in.
Oh, that's so cool. So I'm just thinking back to my own the podcast episode. If you haven't seen it already, quick plug. Sophie Harker and I, we already had a podcast episode together. And I remember when we were speaking about this, like looking at these deep space missions, especially the ones to Mars, she was like, oh yeah, there's a chance that if you go out there, you might not always come back because and the astronauts know this. And it's just, that's really shocking to me as somebody that's not in the space industry like you guys are. But I see the way that you have to plan for that as well, especially with the AI systems that you're bringing in. So planning for, what happens if the worst does happen. So just looking at that backup thing as well, which is quite fascinating. So I'm going to head over to ask a bit more questions. Okay. I want to ask, actually, for yourself, Kinjal, so you were talking about as well, looking at like solving these kind of problems. And I wanted to ask, like, when you were working at, for example, one of the places that I saw that you were doing was Corda. I'm not sure if that's linked to the defense consulting, but if you could talk about some of the ways that you guys are able to, like in your defense consulting, take care of either the aircrafts that you're working on or like the people that might be in some of the things that you're working on, like the satellites that you mentioned. Could you talk about how you're able to like plan for that and making sure that they're safe and they're coming back in the end? Very strange. Okay. All right, I'm going to pause on that question. We'll come back. So Hasret, I'll come over to you. So I want to ask, so you were talking about how, or at least even in the bio that you had, we were looking at the different educational systems that you're working on. When I was looking at your profile, it was quite a few different educational paths that you were looking at. So you already mentioned a bit about the University of Oxford, I believe, with Cosmic Girls. And then you were also doing some work with NASA in terms of getting more people involved and getting them educated in space. So I think it's really relevant, especially now, because we're talking about students that want to get into the space and the aerospace industry. So are there things that maybe you've noticed or like little strategies that you're able to give to the students to help them to try to get more involved or to try to get more experience that you might be able to share?
Yeah. for the beginning, I think the NASA has some programs like the citizen science programs, and for example, I have started from there. So they have many programs related with biology, related with, in some sense, economics, related with space. Like for example, they have a program like Stall Catchers. They're working on the Alzheimer's issues, the blockings and other things, for example. And they have like the disk detectives. They're trying to find out the disks in the space. There are a lot of other things. So, I have started with that. It is like you can increase your focus as well. Because, yes, I have different umbrellas, but we are like living a life, like the orbit of the Earth. When the Earth is moving around the sun, it is facing the moon. It is coming to face the Mars and other planets as well, the neighborhood planets. So while we are living our lives, on the way we can face people, we can face the fields and other things. Because if they want to go to the space is open to all the fields. Because, while I am teaching the space exploration course, for example, I have divided into 5 parts. I just wanted to give examples to the students in order to get the necessary views. For example, the space expedition. You should know about the solar systems and planets, and for example, the journeys to the moon, journey to the Mars, and I have the space economy. For example, while you have asked the question of becoming the lunar analog astronaut, the Sophie has explained it in an excellent way. But the other point that I wanted to mention as well, the cost. Because whenever you send the people to moon, for example, in order to make the necessary experiments there as well, there is a lot of cost. In order to decrease cost level, you make the simulation on Earth so that you can face the same environment and you decide about the experiments, but the cost level is becoming too low whenever you compare with the space. So this kind of things are really important as well. If the student they didn't decide about what they want to become, they can go to the like as I said, to the NASA citizen science projects, and they can just try to include themselves there so they can get the necessary information, and they can look for the programs like the programs, STEM programs, because these days, because everybody wants to move to leave Earth and go to another planet to live and try different experiences. Because of that, you can find a lot of programs. If they search like STEM programs, they can see a lot of programs. They can see them, some people teaching at the university, some people teaching at the secondary schools or some private institutions. So this kind of things are really important. And but they shouldn't forget that they should have the necessary network, because the necessary network is really important, as you are doing now, because get experiences, you can find an opportunity to know different people, and maybe they can open your way. Even with this, for example, I'm learning from you now, because every time we are learning from each other. And so I think I can follow in that way, because in the space they are making a complement. Everything is a complementary. Economy, engineering, for example, the becoming biologist, and the drawing, art. These kind of things are complementing the life, the experience that they want to become, so they can follow this kind of things, I think. And
I'm so sorry. I don't mean to cut you off, but just only because I'm trying to keep an eye on the timing as well. I'm just gonna move over. I'm so sorry. But everyone that we're listening, I'm thinking that we'll just create a list later of some different programs that you guys can look into if you're more interested in getting some experience. I'll reach out to you, Ms. Hasret, to get a list of different programs that they can join into. So she mentioned the NASA, a bit more at the University of Oxford, and then just, creating networks like this. You guys coming to events like the LinkUp, for example, and speaking to these wonderful women about what they're working on, and you can learn from them. And that gives you that network and experience. So if you haven't already, hint, hint, look them up on LinkedIn so you can connect with them and speak with them later. So I'm going to come over back to you, Ms. Kinjal. I wanted to ask you about defense consulting. So why did you get into it? And then also, what do you find so rewarding about it now? What do you enjoy the most?
Yes, thank you very much. And good old IT troubles. Okay, so we heard about like the fight with IT, fight with AI, fight with thermodynamics, and fight with money. The thing that really sort of excites me about consulting is that the bottlenecks of the supply chain and how that affects our clients, like the space agencies or the Ministry of Defense, from a money or an economic perspective. And I also get to see the hardcore engineering and the nuances around that, or how innovation can actually overcome some of the inherent challenges, like we have, for instance, making an aircraft fast. There's only so much you can do, but you can do some innovative engineering, and Sophie might be smiling with this. Like if you have an afterburner that can just have a very interesting propulsion technique to make the aircraft go a little bit faster. What comes with that is several other challenges with materials, with a few sensor systems which are not communicating properly with the aircraft. What about the cost? How do you manage it? How do you justify extra funding? So as a consultant, I sort of see things from ideating from first principles, and then taking on the life cycle approach. So, whether it's in service, whether a piece of tech is added to something that's in service, and when it's in service, how do you then dispose it? What do you do with the end of life? When we talk about space, we must mention, space debris. How are we making sure that missions are having the end of life approach incorporated within? Also, from a safety perspective, when something is in service, are we making sure that we're sustainable, we're impacting less lives as possible, we're not polluting the oceans? What about, sustainability in terms of not just the environmental impact, but the social impact? Are we getting our workforce that is sort of more representative of the society? So yeah, I get to deal with the hardcore engineering and the softer sort of, not that economics and social side of things is soft. One can argue that's probably fundamental, but I get to see both sides of it, which is what makes it really exciting.
I love that. And I think just because there's so many of us, so many of you all really in this panel from different nations that we have. Sophie is in England. I think, Kinjal, you're also based in England at the moment. Hasret is in Cyprus. Cheyenne, you're originally from Jamaica. So I think one of the questions that I had when I was looking into it was seeing like this role of emerging, I guess you can call them space nations, just like the big countries where innovation is really happening. So we have like the US, Russia, things like that all coming together. So I wanted to ask you guys about how do you see the role of these like emerging different nations coming about, and how we can start getting involved in them in the different, like the space industry mostly is what I would like to focus on. So what would you say about the role of these different countries all coming together? I'm not sure I should ask. Sophie, I might ask you actually.
Yeah, I can start that. Yeah, it's space is one of the very few industries in the world that is a truly global industry. It's never a one country race in space. Even when you look at the likes of like the space race back in the 60s, it still wasn't just the US and just Russia. There were other parts of the world that played a part in that. And now it's the case now. So if you take like the superpowers of the space world, so you have like the NASA's in the US, you have Roscosmos in Russia, and those have obviously come from a long time ago. But then if you look back 20, 30 years ago, the Indian space industry wasn't very big, China's wasn't very big, and now they're two of the biggest in the world. And then obviously I can't fail to mention the European Space Agency with ESA, and that's growing pretty much year on year with new countries joining European Space Agency, and it gets bigger and bigger. And it's more than just sending people to space, which, you know, I want to be an astronaut, I love that stuff, but it's way bigger than that. There's a lot more to it than that. So if you look, for example, at like when you're using your Google Maps or any other map service you want to use, people go, oh, I'm using GPS. Well, you might be, but you may also be using a different satellite constellation that's not GPS. And that is done by, for example, ESA. They have their own version of Galileo. There's a bunch of other ones that are out there. And what I'm starting to see anyway in sort of the smaller satellite industry, because there's the big ones and then there's the smaller sort of constellation type of satellites, is there's lots of different countries that are wanting to build their own capability, that haven't historically had them before, and are looking to partner with nations that already do that. So it's definitely becoming much more accessible for countries all across the world to have like a national capability instead of relying on those big ESAs and NASAs and people like that. So it's a very, like I say, very global industry, by nature, like it has to be, and I don't think that's going to end anytime soon. And that's one of the things I love about the space industry is it feels very small, but it's, as in, you know, there's not too many people in it in comparison to, say, IT. It's much smaller than that, but you get the whole globe in that small community. So you get to interact with people from so many different parts of the world in that community very, very easily and pretty much on a daily basis. So yeah, it's one of the things I love about it, actually, is that international component to it. If that answers your question, or somewhat answers it.
Definitely. But I also wanted to ask Cheyenne to pull in on this as well, because you've been doing a lot of work with bringing Jamaica more into the space fields. I won't explain it. I'll get you. I would like for you to kind of talk a little bit more about your work that you've been working on.
Okay, so currently I'm having discussions with the International Astronautical Federation. And what that is, it's a global organization that brings countries together from all over who are involved, who are interested in space. So there is a region, the Latin American Caribbean region, and I've had a few meetings with them, and I'm trying to get more Caribbean islands involved. As the last meeting I attended, I was the only one from the Caribbean, English-speaking Caribbean country that attended this meeting. And so I have actually spoken with the universities in Jamaica, and I am trying to expand from there as well, trying to explain the importance of space, how they can contribute as well, because from the Caribbean island, during my research and from attending these space conferences, such as the International Astronautical Congress, IAC, which is actually hosted by the IAF, the federation, the organization that I'm having discussions with, as a Caribbean islander, I noticed that our skills and expertise, the skills that we have just from, you know, being innovative and creative and working with what we have around us, can be very useful in the space industry. We can once we are able to adapt ourselves to different environments. I'm not going to say the sky's the limit, because it's not. It's limitless, our capabilities and our skills. So that is one of the things that I'm trying to do. I'm not limiting it to Jamaica, so I'm trying to reach out to other Caribbean islands. You and I have spoken about this, Cameron, about about expanding a bit more. So yes, that's one of my missions, and that's what I'm actually actively doing at the moment.
This is also fascinating. So just a quick little PSA to the attendees. The questions, you can ask questions at any time, but if you would like to kind of speak with some of these wonderful people, if you've seen you've been listening to them with their different accolades and the things that they're working on, if you yourself are already in aerospace, maybe you want a little bit of advice, these are the ladies to talk to. Just saying, we have so many different ladies in the room. Because when I had asked one of my friends actually who's doing aerospace engineering, I was like, do you know any women in the field? Like, were there any professors in your class? And he was like, now that I think about it, no, we didn't have any aerospace, like the women that were in the aerospace space field. So I'm just saying, guys, this is the perfect time for you to kind of speak with them and ask them some questions because we have 4 of them here for you. So just let me know if you need anything. But in the meantime, I'll just keep it moving. So I wanted to actually ask, I guess, some more questions. I think, Kinjal, you might be the person to ask about this with your experience as a defense consultant, because I saw that you were also looking at, like you had also worked in like the central government, international government, and also with some commercial clients. If you could talk a little bit about, I think what's really interesting is space tourism, which one, explain what that is, and then also how people might be able to learn a bit more about it. Like what should we be looking at as we start thinking about space tourism? Because I find it kind of fascinating.
Oh yeah, I mean, who doesn't, you know? So one definite movement in terms of space as an industry is happening towards the direction of inclusivity. So back in the day when you first went to the moon, it was just really, really fit, very well-read Air Force pilots, test pilots, who were at the peak of their fitness. Most of them were men because, you know, they didn't know what radiation did to our bodies back in the day. And now it's becoming much more inclusive in terms of physicality, in terms of mental capacity, and also economics. So what happens now is, you know, when you have ESA announcing that we will train and send an astronaut or differently abled astronauts in space, it gets people like, you know, Richard Branson sort of jumping up and down and going, what if I can capitalize on this? So with space tourism, it is extremely exciting, and there's a lot of work happening in the US in terms of capitalizing on space tourism. So what they're trying to do is make the engineering more and more robust. So people like you and me who are perhaps not as, I mean, I can only talk for myself. I don't know about you, but perhaps not as fit in terms of fitness levels, or not as robust in terms of learning a new language or a software system just to go on space in 3 months or, you know, even less, can enjoy the benefits of space exploration. So Virgin Galactic is making their spaceships or space travel extremely friendly for people. One company that you should be looking at and following, they're doing some really cool research, that is Virgin Galactic. And I think you can also register, you and I can register to be on the next commercial space mission. It is quite expensive, but I mean, they're trying to also lower the cost to accommodate for that inclusivity factor. What actually happens with space tourism is that you can get, you know, commercial clients who can have bases in India, in parts of Australia, in the sunny Caribbean islands, and UK and USA. And you can actually get a lot of companies within those specific ecosystems and those countries contributing to the wider good. So when you're looking at ESA or NASA, because of the space asymmetry and because of national security aspects, national laboratories wouldn't allow non-US citizen to work on something or non-European to work on something. When you get a commercial player in place, confluences are more, and national security aspects are less. So the conversation differs slightly, and you get more components of inclusivity and collaboration. So, I mean, SpaceX is also looking at doing something like this, but Virgin Galactic they've already sent a couple of commercial astronauts in space, and they're looking to make it even more inclusive, less and less exclusive with their tech and science. So yeah, that's my take on space tourism.
So fascinating. And I think I'm going to come back to you, Sophie. I'm trying to ask questions from a range of different participants, but I remember in our episode we had talked a little bit about the green challenge, I would say, in terms of when you're putting things into space. Like, for example, you put something in there, is it supposed to stay there? Is it coming back? So I'm not really sure. So I wanted to ask you about what the green challenge is, and then how can students really prepare themselves to get involved in something like that?
Yeah, there's a number of sustainability challenges with space and aerospace as a whole. So that's aviation and space together. Specifically on space, is the number one, as it were. The main one is space debris. It's a really big factor. One of the I don't know if like we could share a photo somehow of a picture of Earth from a distance, and you'll see all of the satellites that surround Earth and all of the sort of like old bits of spacecraft that still exist there, and they're just floating around, and they will be floating around almost forever. So most satellites you send up now, so what we'll send up, for example, we have what we call a controlled descent. So we will bring them back down to Earth once their life is over, and they'll burn up on re-entry into Earth. And they're very small, so they're not going to be creating a huge amount of anything that comes, like you won't see anything come back through. But there's a lot up in space that can't come back down, and even small things like a speck of paint sounds really silly, like, oh, who cares about a speck of paint? Well, the ISS do for a start, because if you're flying a small teeny tiny piece of paint, even though it's tiny, flying around at the speed they're flying around, which is like hundreds of thousands of miles per hour or kilometers per hour, depending on what you're looking at, very, very fast. A teeny tiny speck of paint can make a crater, like an enormous crater in the side of another spacecraft. So that could either be another satellite, or it could be something like the ISS, and you could actually cause some serious damage that can be life-threatening to those astronauts. So there's a number of things like that that are a real issue. So one of the big issues with that is, how do we get rid of it? And the answer is, we don't really know. There's a lot of ideas out there. So there was one about a harpoon, which is like like an arrowhead with a net out the back of it. It sounds interesting. I'm not sure I'd want to be on the receiving end as an astronaut on the ISS of a harpoon. And there's a bunch of others about like looking at how, well, can we have like a space Hoover, and how do we get rid of these parts, as well as some of like the bigger parts, and understanding how we get rid of those. So there's parts of like the Apollo missions that are still floating around in orbit, completely useless. They don't do anything, but they're just there. So it's basically a big junkyard. And then the more you've got there, just like you have with more cars on the road, the more likely you are to have a crash. So that is a big issue. You then also have the sustainability issue right down at the bottom on Earth, in that a lot of the things that we need for space, like for example, lithium-ion batteries we often need for space, solar panels, we need a lot of very specialist materials that are high integrity materials, that have detrimental impacts to Earth. So if I take lithium-ion batteries, for example, is when you mine for lithium, you have quite a lot of environmental issues like water pollution. When you mine for cobalt, which are also in lithium-ion batteries, you also have a lot of social issues. There's a lot of child labor in that. There's a lot of corruption and bribery, and a lot of these things, like further up in the train, as well as manufacturing that battery, uses a lot of energy. It pollutes a lot of CO2. So it's up to people who are buying those batteries and using those batteries to put that requirement to say, we're not going to tolerate bad practices earlier in our life cycle. So that's a really tricky thing, because it has an economic impact. I'm sure Hasret will be able to tell you, as well as it's not a very easy answer. It's not easy to track. So there's a really big challenge in that. And that's the same of whether it's a lithium-ion battery for a satellite, whether it's the same as ultra high integrity material for a rocket, or if it's just a lithium-ion battery in your iPhone. It's the same problem that people all over are trying to solve, and space is just one of those customers that are trying to help.
Wow. And I think I'm going to head over to, but I think that that's really interesting as well, because one of the things, well, I'm not in aerospace, but one of the things that I've definitely heard from some of my friends that are doing aerospace and also looking at the space engineering. Sorry, I should stop using these interchangeably. Two different things, guys. There's aerospace and then there's space. Aerospace is looking at the aircrafts and things, but they're quite similar. But I'll let you
Aerospace covers space and aviation.
Right.
So if you say aerospace, it includes space.
Right.
If you say aviation, it's just aircraft, and then aerospace is the two.
Thank you.
So if you say aerospace, you're fine. That covers it both of them.
Thank you. I was a little bit worried, but thank you. One of my friends says he's doing aerospace. He was looking a lot at things like, for example, the nuclear energy, which is what I think Kinjal was looking at as well. So looking at how you mentioned already, like little small things for paint, but also just looking at how if you need to be able to take these big aircrafts into space, how much energy is that going to take and where are we getting it from? I think that that's really interesting as well. So looking at there's a lot of different things you can do for sustainability in space, which is quite fascinating. I'm going to ask another question. So we're looking at, just in case, guys, we have plenty of time, well, about 7 minutes. If you guys have any questions that you would like to ask the panelists, do feel free to put them in the Q&A session or just raise your hand. I'll be keeping an eye out. But in the meantime, so I'm not sure who would be the best person to ask about this because we slightly touched on it before. But looking at, for example, NASA's Artemis program, because I think that they're looking to return humans to the moon and eventually Mars. So I think we touched on this before, but what would be some of the, I guess, key technological and maybe even some of the logistical challenges that would need to be addressed before we even, I guess, approached something like that? Not sure who might want to take that one on. I'm not sure who I can ask. Hasret, or maybe Cheyenne. I'm not sure who I could ask.
So because my expertise focuses on explainable AI, I can only speak on what I know from my studies and the papers I've read and some of the conferences I've attended. So okay, so some of the key factors that as humans, what we do need resources for just life support and with regards to the equipment required on board, there will be, well, I can't speak for exactly what equipment exactly, but they would need there's a supply, they have to be ensure that the astronauts have enough supplies on board to keep alive for the mission, for landing. Regarding where, they'll have to do a lot of analysis of like environmental conditions and well, for Mars as well. Well, you already know about the Mars missions that have been taking place where they're taking pictures and analyzing soil samples and studying the environment and the atmosphere. Of course, we need to know these things in order to ensure that if it's humans we're sending, that we can build or create an environment that is safe. So there are some companies actually that are looking into this with regards to building structures on surfaces of planets, and they're looking on different types of materials. So and I've also spoken with biologists as well who are looking into this. Yeah, I can't really say much.
That's okay. I might pause for Ms. Kinjal because I think Kinjal had something she wanted to add as well. And then
Can I add?
Yes, just like a few minutes, and then I'm going to get you guys to give some advice as a wrap up.
Yeah, of course. No, I just because I couldn't, from a consulting brain, I just couldn't stop myself. I mean, from my perspective, what I see a large program with a lot of loose ends, lots of complexity, and a lot of ambition, right? So what we have here is that, key vehicles, key systems. So space launch systems, rocket systems, other sensors, other human flight interfaces, other key architectures. We have a bunch of other AI systems, other communication systems that have to function on their own, but also together, right? So from like a systems engineering perspective, from a holistic perspective, we have where is hardware and software talking to each other, have to be tested to the limit, right? And tested by people like, Sophie herself, like analog astronauts, that they're working, that and that there are did face a few delays because of these very reasons. So we have to look at like a life cycle perspective, like a holistic perspective. What are the components? Where are they made? How will they be shipped? How much fuel will be used to ship them? And where will they be sort of manufactured and assembled together? Who will be assembling them together? How will they be tested? And how can we make sure that all of that is done on time, in budget? And the big S question, the safety question. So unfortunately, our industry, aerospace industry, is a very reactive industry. So we wait till the plane crashes or there's a huge turbulence on Singaporean Airlines, and then we say, we didn't think of this, or every air crash will make planes better. Instead of that, I think what we can learn from other industries like the energy systems or the nuclear systems is to inherently make it safe, and the safety being a huge part of the discussion from the very top. We make them very ambitious. European Space Agency is actually pretty better than NASA. I can say this when it comes to safety. Even our companies are much better in commercial aircrafts when it comes to safety than some of our US counterparts. But in order to get something in time and on budget, we sometimes compromise on safety. Let's not do that, because in Artemis, I think one of the components was tested and failed, and they had to run the entire test again. So just because they didn't want to repeat the Challenger disaster. So yeah, there are so many loose ends, and there are so many things that have to go right, and on time. So yeah.
I think I'm gonna have to pause you only because we have a question. Thank you so much. So we have a question, and I know it's gonna go over time, but I'm gonna get it answered anyway. Don't worry. So we have it says, it's from Kurti. She says, "Hi, thank you so much to all of you for this opportunity. I wanted to ask a question about eVTOLs. AIBot is an eVTOL company that is similar to Tesla in that it has been running algorithms on its vehicles in order to accumulate knowledge and advance its AI software to pilot the vehicle. What do you see as the primary technology and safety hurdles that we would need to overcome to reach this stage? And would you have any thoughts about this, about how this would influence urban air traffic, for example, using eVTOLs as a part of a taxi service?" Not sure who I can bug. It might be you, Sophie. I might have to go over to you.
Yeah, I can answer that. That's okay. Yeah, I spent 3 years working on eVTOLs. So it's for those who don't know what an eVTOL is, it's an electric vertical takeoff and landing, also known as an air taxi. So the big ones are like Lilium and Joby and companies like that, Vertical Aerospace in the UK, like a lot of big companies that have started over the last less than 10 years, really. So the AI argument in terms of control software, I'm sure Cheyenne will be able to tell me a lot more about the AI that actually goes into it. So I will take it more from almost as a customer perspective as the aircraft designer. So similar to what Kinjal was saying, is that safety is paramount in aerospace. We don't trade it off, let's put it that way. Like it's number one. It's always number one. There are things that fall through the cracks because we're human and things happen, but it is always number one. And whenever we introduce anything to do with control, so control is what we call a safety critical system. So without those control systems, the aircraft falls out the sky. So anything to do with control has to go with the highest certainty that we know it's going to go right. So it's something like 10 to the minus 8, 10 to the minus 9, or probability something will go wrong. So that's like 0.00001 chance that would happen. So you're talking 1 in every like 10 billion flights that something might go wrong. So you're talking very small probabilities. To get AI outputs to prove to that level of certainty is very difficult at the moment. It may be possible. I'm not saying it's impossible. Aerospace, and this is where the reactive comment comes in, is they're reactive to wait till the AI industry can prove it, if that makes sense. So that the safety argument is the biggest, hardest part of using AI as part of control software. That being said, they can take like an AI image. So once I'm assuming it's machine learning you're talking about here by your question that you've talked about. Once you've learned the algorithms learned enough, they can pause it and go, okay, this is the snapshot of the software we're going to use, and then test that software and prove that does what it's meant to do. It's called neural net. They can absolutely do that. That's no problem. I say no problem. It's still fairly new for aerospace, but they can do that. That's one of the things that has been revolutionized in the past 5 years, let's say. But what they can't do is use like a live machine learning that is constantly learning, oh, this pilot flies it this way, so if I overcompensate in this place, it'll mean they'll fly better, or they'll use less battery, or whatever it is. But it cannot do that because there's just no safety regulation to prove that it would know what to do. And the recent incident with Boeing is a really good example of why you don't mess with the control system, because those things go wrong, and it goes horrendously wrong. I hope this answered your question. eVTOLs in that world it's a really really complicated certification world because we don't have them yet. There's no eVTOL certified. There's only one electric aircraft in the world that's certified, and it's not an eVTOL, it's a fixed wing light aircraft. So even just getting them certified without any AI components is a really big challenge. So once they tackle that, then I can see them going, okay, now we'll look for uncrewed and machine learning and AI versions of those vehicles. They're not going to be the first ones that come through will be standard piloted, very simple, like bounded control software, if that makes sense. But Cheyenne, please feel free to contradict me in any way.
I will unfortunately I have to cut it for today, only because I know it's just like it always gets so good at the end. I didn't get to all of you, but for the people that did stay on, thank you so much for staying for the extra time. I think I wanted to get you guys to give some advice to some of the girls in terms of like getting into the industries, but I might get you to just write that down and I'll put it as a post for later. So thank you all so much for joining me, and thank you to each and every one of you for your time and for your explanations. And I'm so sorry we didn't get to go through everything, but I'm thinking podcast episode. That's what it sounds like to me. More time in individual podcast episodes for the next time. And thank you so much. So the next session is happening in about 10 minutes. So we're going to be talking about generational knowledge is power. So we have Dr. Karika Weldon from Kara Genetics coming to speak with us. She is the first woman to own, she's the first woman to solely own a genomics company. So she'll be speaking with us in about 10 minutes. So if you have time, feel free to join us and hop over onto that session. It'll be in 10 minutes and I will see you there. Thank you all so much again for your time. I'll see you at the next one.
Thank you.
Thank you.
Thanks. Bye.
Okay.